Well, hey there, unassuming friendly neighborhood AP Physics 1 student. Did you know that motion in the projectile motion is parabolic or parabolic? That's what section 3.7 says, and I don't know if you've noticed, you guy there, all projectile motion is parabolic. Take, for example, an object that's flicked and then falls in the vertical direction while moving in the horizontal direction. I believe that's a parabola. And what about objects that are punted? Right? When objects are punted, those are also parabolic. It just so happens that we can show that projectile motion is parabolic with math as well. And that should make sense and not be terrifying to you whatsoever, because every situation in physics can be supported with the equations. That's why those equations exist. So let's do this, folks. Let's show that all projectile motion is parabolic. Alright, to show that all projectile motion is parabolic, we need an equation of y as a function of x. So that means that we're going to need the connecting point between x and y, or some way to substitute the equations from the x direction into the equations in the y direction and vice versa. Right? Because if we're going to combine the x and the y pilot, we need to have something similar about them, because we know for certain that the x and the y components of the motion are completely separate. And there's only one thing that connects the x and the y components. If you said time, you're correct. So let's go ahead and let's think about this. Like I said, and it's really important that you remember this, right? The x and the y components of motion are completely separate. We can solve for them completely separately. X motion is given by the velocity in the x direction times time, and y motion is given by the kinematic equation resolved for the y direction here. Now, we want things to be as simple as possible for us, because why make things difficult if we don't need to? If we're going to make this happen as simply as possible, we're going to make whatever motion that we start with, right? Wherever our motion starts, we're going to say that it starts at the origin, 0, 0. And that way we can get rid of some pesky values like the x and the y naught. I've already eliminated the x naught here. The y naught is now gone also. And you can see, for the sake of this equation, I've set my axis so that up and to the right are our positive x and y values, which is why I have -1/2 gt squared. Now that I've done that, we know that the relationship or the connecting point for x and y is time. And here I have time in two fashions. And over here I could solve easily for time equals x over v naught x. Right? So now I have what time equals in the x direction, and I have time over here. And I'm looking for an equation that connects x and y, or an equation where y and x are connected. And the connection is time, so I'm going to take this time here and I'm going to plug it in for these times over here. And that means that I no longer need to worry about keeping them separate, because I'm literally putting them together. I'm going to say that y equals vy naught times time, which is x over v naught x, minus 1/2 g times x over v naught x squared. I can do some simplifying now, so I'm going to do just that. When I simplify this equation, I get that y equals vy naught over vx naught times x minus x squared over 2g vx naught squared. Another way to write that, I could pull the x out of this equation and put it next to it. But like what I'm gonna do now is I'm gonna remind you that this vx and vy are not completely two separate variables. They're actually just components of one variable, and that one variable is whatever the original velocity is. Right? So that means that we can find the relationship between the vertical and horizontal velocity by returning to our original velocity. And so that means that vx naught is going to be v cosine theta, v naught cosine theta, and vy naught is going to equal v naught sine theta. And so I'm just going to go ahead and I'm going to drop those into this equation right now also. But if you look at this, it's a little bit messy, but we've already accomplished what we meant to accomplish. It's just that now we have these horizontal and vertical components that don't have any relationship with each other, and we want to simplify things as much as possible. So here we go. Y equals v naught sine theta over v naught cosine theta times x minus 1 over 2g v naught squared cosine squared theta. And that should look familiar from the range equation, only we were substituting alternate values there. So here, I don't know how my g got on the bottom here. It must be, you be tripping. That g belongs on the top. Sorry. So now that we have our equation here, we can simplify it even further by saying now that I've eliminated the velocity component in this portion of the equation, I've corrected where my gravity belongs, because let's face it, it was at the top up here, so I don't know what I was thinking when I put it down there. Just brain. Now I can simplify it even further using a trigonometric identity, and that's sine theta over cosine theta equals tangent theta. So my simplest form of this equation is y equals tangent theta times x minus g over 2v naught squared times cosine squared theta times x squared. And this is as simple of an equation as I can provide. But if you take a look, these are going to be numerical values when we solve them. Right? And these numerical values are going to be constants because these don't change. And if you think about what the equation for a parabola is, the basic format is y equals ax minus bx squared. So that makes this an a value and this a b value, right? They're just the other non-changing variables in the equation. So this makes a function where y, or the height, is dependent on the value of the position in the horizontal direction squared and directly. And this is a projectile motion, or a projectile parabolic It makes a lot of sense now, but back in the day when Galileo had the ideas, this was on the forefront of studying physics. People were trying to collect all sorts of data to confirm whether or not this was true. This idea of creating a system of equations or creating a relationship between two completely separate forms of motion, two completely separate components of a problem, and putting them together with what makes them similar is a key idea for solving for problems, especially complex problems. And we're going to be using this exact same idea in our lab.